Welcome back, Rockstars. Welcome to PSRock Day 1, Let the Games Begin part. So I'm going to skip over the slides we've already gone through and jump down to slide 9, Simulations and Models. So please make sure that you download and either print out or open up the guided note document that goes with this lesson. It will help you make sure you understand what's going on. So simulations and models. In computer science, a simulation is a way to model a real-world activity, something that goes on. So we might want to model like the COVID-19 virus and how it spreads between people, how quickly, based on are we obeying social distancing or not obeying social distancing rules. In this case, for rock, paper, scissors tournament, we're going to model a different number of teams where they all have their own algorithms for how to play the game. So we can model an activity by developing code that acts or reacts like the real world activity would. So in rock, paper, scissors, we can start with some simple strategies, right? So our algorithm could be, I'm just going to throw rocks all the time, throw rock all the time. Or I'm going to throw paper and then scissors and then paper and then scissors, right? And then we will see how, just like in real life, right, if you spot a pattern like they are throwing rocks all the time, you can change your move to beat them, right? Or if you spot that they're always throwing paper then scissors, you can change your moves to beat them and try to win the tournament, right? So by modifying our model and running additional simulations, we can evaluate, we can check out how these changes behave, what happens with them, and are that will allow us to improve our algorithm and increase the number of throws we win, so we can do better in the tournament. Plowing ahead. So the main way we're going to improve our algorithm, right, is by running a simulation, reviewing the results. Right? And as we're reviewing the results, we're going to look for patterns we can detect, right? And if we can detect it with our eyes, we can figure out how to write that code so we can detect it in Python as well. And once we detect a pattern, the assumption is we'll be able to predict the next move, and then we can easily beat that move, right? So if they're throwing rock, 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 I predict their next move will be rock, right? And I can beat that. And actually, I'm going to predict, all I'm going to check is, are they throwing the same thing over and over? If they are, I predict they're going to throw that same thing again, and I can beat that same thing. So in PSRock and rock, paper, scissors in Python, we're going to use letters to represent moves. So R is going to represent rock, P is going to represent paper, and S is going to represent scissors, right? And then when we're asked for our next move, we're going to be given a string with all of our prior moves called my history and all of their prior moves called their history, right? And I went through this in part 1, okay? So letters for the moves and strings give us all of the previous. Last week in lesson 7 in Code High School, we learned that Python allows us to treat strings very similarly to lists, and we can access each character in a string by using indexing, right? And we remember indexing and lists from MIT App Inventor and indexing and arrays from Vex Coding Studio. Now, Python loves lists so much, they actually give us 2 different ways of indexing, right? They give us a way that we can index from the beginning, from the start, using positive integers, or from the end using negative integers. And it almost matches up perfectly with how we talk about it, as long as we keep in mind Python likes to start counting from 0, right? So our first move is going to be index 0, right? So if this is their previous moves, right? Rock, and then they did scissors, paper, scissors, paper, scissors, paper, scissors, paper. Their first move is going to be index 0. Their second move is index 1. Their third move is index 2, right? Because that's because we started counting from 0. Instead of counting 1, 2, 3, we're going to count 0, 1, 2, right? And how would this extend out, right? Their fourth move, well, I think you see where that's going, right? That's going to be index 3. And their fifth move, that's going to be index 4. Now we know that. That's just basic indexing. We've gone into, well, I can start counting from the end. Their last move is index -1. So if I plug in their underscore history brackets -1, I will get this S from the very end. Right? Their second to last move is -2. Their third to last move is -3. This is exactly like it sounds. Right? Their last move, -1. Their second to last move, -2. Their third to last move, -3. Python loves lists so much they came up with this negative indexing to make it super simple to pull stuff off the list from either end you want. Down. There we go. So one more time, just spelling that out. When I say my first move in Python, I'm going to say my history 0. If I say my second move, I'm going to say my history 1. If I want to go from the end, I'm going to use negative numbers. So their last move is their history -1. Their second to last move, their history -2. Their third to last move, their history -3. Okay, that may seem obvious. Let's see how we can go use it. So I want to detect, I want to see if they're doing the same thing over and over. So when I'm asked for my next move, I'm given all of my previous moves, all of their previous moves. So let's say their history, okay, so their history equals RR. Okay, so this is, their history 0, their history 1, their history 2. We're looking from the end, their history -1, their history -2, their history -3. Now, how can I check that their last 2 moves are the same? Right? Well, if I kind of do that in pseudocode where I'm still using English, but I'm speaking like a computer, if their last move, right, their last move is equal to their second to last move, right, then I know they played the same thing twice in a row. Their last 2 throws were the same. So how can I convert this pseudocode, if their last move is equal to their second to last move, into Python, right? It's almost written for us, right? So their last move, I know that's their history -1, right? I'm starting from the end. Their last move is -1. So if their history -1 is equal to, right, that's equals in Python, right? If I want to compare something, I'm going to use 2 equal signs. Their second to last move, well, okay, well, that's their history, and second to last is -2. So I can detect if their last 2 moves are identical or the same if I say if their history -1 is equal to, equals, their history -2. Okay, and these 2 lines almost read the same once you're used to looking at Python. Okay, cool. Now we've detected the pattern. Oh, but I don't see rock or papers or scissors here. Do I care? Great question. I actually don't care. Right? I'm detecting a pattern. If I know they're repeating, do I really care if they're repeating rocks or if they're repeating paper or if they're repeating scissors? No, I kind of don't. It's a basic pattern. It's easy for me to detect using their history -1 and their history -2. All I need is some way that, I can say, I predict their move is going to be this thing. I don't care what it is. I don't care if it's rock, papers, or scissors. Give me the move that beats it. Okay, and that's just a simple function, right? All of you guys know I can give you any move and you'll tell me what beats it, right? So if I tell you their move is going to be rock, you're going to say you should throw paper, Mr. Benoit. That's how you're going to beat them. If I tell you their move is going to be paper, you should say you should throw scissors. And if I tell you their move is going to be scissors, you're going to say you should throw paper, right? So here's the function. It has if the move is rock, return paper. Paper is the move that will beat them. If the move is paper, return scissors. If the move is scissors, return paper. I screwed that one up. See, teachers make mistakes all the time. That's why we do this stuff online. We don't, chisel it into stone. So if they throw scissors, we should return rock. Rock beats scissors. Okay? And look, I don't have to, that'll be clear in the next page. Okay, so if we put it together, if their history looks something like this, where their last 2 moves are the same, It doesn't matter if it's rock, rock, or paper, paper, or scissors, scissors. I can detect that using the simple if their last move is equal to their second to last move, right? Which is down here. If their last move, their history minus 1. If their last move is equal to, equals, their second to last move, their history minus 2, right? That literally means their second to last move, the second to last character in that string. If that's the case, well, I can just call beat move because I know how to beat all that stuff. I'm smart, right? What do I fill in here, right? So what's the thing that I need to pass to beat move? Sorry, I didn't mean to click that. What's the thing I need to pass to beat move? That's my prediction. Well, I'm predicting that they've just played this twice in a row, that they're going to play it again, right? What's their last move? I can just pass in their last move to beat move, and it will tell me how to beat it. I'm not going to write that down. If you guys are following along, you know what goes in here, okay? You got this. I know you do. So, in Replit, what are we going to do? Let's go do this in Replit. Let's open up Team 1. So you guys have set up Replit. You know how to navigate, okay? Here's team1.py. So they're going to import random. We talked about that. They have their strategy name. We talked about why that's important. Here is that beat move function, right? So if, let me make this bigger so we can all see, right? So if move equals rock, return paper. If move equals paper, return scissors. If move equals scissors, return rock. Okay? And then this is our main, this is the main function that's going to get called for the tournament. We're going to be asked for our move based on our history and the other player's history, our opponent's history. Okay. If we haven't played 2 moves yet, now we can't be checking what their last 2 moves are. So for the first couple of rounds, we're just going to play rock. Okay. And then we can get into the if their history minus 1, right? If their last move equals their second to last move, we're going to return beat move of their history. Otherwise, in here, it's got a random choice. We may do something else. Okay, so this is Team 1. This is an awesome starting point. We want to create a new file. So we're going to come over to our file manager, right? Make sure we're on the file manager, right? And we're going to click on the page with the plus sign next to it, which means add file. And we're going to create a team of our own. I'm going to call this team Fred. Why Fred? You guys will find out soon. I've been using Fred as a name throughout the class. It's about time you guys learn who Fred is. Okay, so it's creating this file. It's a little bit slow right now. Pause the recording. Okay, it finally came back. It started up Team Fred. What do I want to put in Team Fred? You know, I just want to do what Team 1 did. This is a good starting point. I'm going to take what they did as my starting code. I'm going to add so much other stuff that this code isn't really, doesn't really make that much of a difference. I just want to see that it will run. So I have my file, Team Fred, teamfred.py. That .py is important in Python. I want to run it. Tournament says I got teams 1 through 5 and Team Fred. Do I want to begin the tournament? Yes, I do. Whoa, here's all the results. There's Team Fred right below Team 1. Yeah, they actually got the same values for everything. Cool. I got some starting code. It's being used. It's detecting a basic repeating pattern. I've got a good start. Switching back to the slides. Okay, so we have that. We selected everything from Team 1 using Control-A or Command-A. We copied it. We went into Team Fred. You guys should call your team something else. There can only be one Team Fred, and that's mine. And we pasted it in. Okay, we ran it, and it showed up just like Team 1 did. What is next? Oh, we're about done, right? That's a good start for today. If you guys have followed along and done everything, you will be able to do the exit ticket really easy. So come back to Replit, go to PSRock period 2. So you're going to come to your home. You're going to click on PSRock period 2 or period. You want to come to your home, click on students, click into our class, and in our class there's an assignment. PSRock beat Repeat1.